Hey guys, Mr. Clarke here again. Just wanting to give you a little bit of a rundown about near-sightedness and far-sightedness, just in case you missed out in class, or if you just want to do a little bit more revision. So the first thing I'm going to do is far-sighted. Okay, so as we know, the light rays come in this direction towards the eyeball here. So you've got the eyeball, and the red part here is the lens. Now the lens can change shape just a little bit, depending on what you're looking at. Now there's a couple of those muscles, the ciliary muscles on the outside of the lens, that sort of pull it nice and tight, or just sort of let it get small and round, and that allows us to kind of bend the light very slightly, just to make sure that the focal point lands right on the end of the retina here. So as you can see with this person, they're what we call far-sighted. So with their normal vision, they're going to see a little bit more of a blurry image, not a sharp image. So we've got the focal point over here where we've got the light coming in. The lens bends the light very slightly, just changes the direction of it. So this sends the light ray down, and over here sends the light ray up, and they converge in the center in that point called the focal point. So you want that to land exactly on the retina, but for this person it doesn't. It lands behind the retina. Okay, so that's somebody that's far-sighted. Now there's a couple of ways that we can correct that. We'll get to those in a second. So the first thing, here we go. Okay, another word for far-sightedness is called hyperopia. Now hyperopia just means that it's just the scientific way that we can explain what far-sightedness means. But light rays are focused behind the retina. Okay, so behind the retina, not in front, not on, but exactly behind the retina over here. Okay, so because the eyeball is too short, or the lens can't become round enough. So it doesn't necessarily mean that the lens isn't good enough. It just might mean that the eyeball's too short to focus the light onto the back of the retina. And so as a result, because it's too short, if the eyeball was a little bit longer, then the focal point would sit there nicely. But because it's a little bit too short, then it means that it's just not going to be focused on perfectly, unfortunately. So objects that are far away are generally pretty clear. Okay, but objects that are near are going to be very blurry. So people probably need glasses to sort that out, and we're going to get to that in a second. And it's corrected with a converging lens, or what we call a convex lens. Now, a convex lens is similar to the one that we have inside your own eye. So convex lens, that means that the little outside bits are bulging outwards. Okay, so a convex lens. And so we just need an extra one just to make sure that that happens. So we can put this little convex lens in right here. Okay, and I'll show you in a second the light rays coming in, and that'll sort it out. So we've got the light rays coming in here. Okay, and this one keeps going straight, this one keeps going in, and they converge a little bit more than they would, or start to move towards each other a little bit more than they would if there was no lens in front of it. So we've got two lenses, and we can double them up just to change the light that the yellow one changes the light that the red one is receiving. And as a result, you have the focal point sitting right on the retina, and that means that people are even up close, anything that they see is going to be in focus now, so they'll be able to have a clear vision of that. So if you can just imagine, so we've got here, okay, so we could even draw some lines really of where we kind of want it to be. Alright, and that's where we're going to want it to be from these rays coming in here. Alright, so that's far-sighted, and I'll come back to these in a second. The second one I want to go through is near-sighted. Okay, so you can see that in far-sighted, the light rays are converging at the back or behind the retina. So near-sighted would mean that the light rays are converging and the focal point is there in front of the retina. Okay, so the same thing happens. It just means that people are going to have very blurry vision as a result. Okay, so that's another word for this is called myopia. So we've got hyperopia, so almost like when you get a little bit of what we call hyper. If you have too much sugar or something, it might be a little bit too getting a little bit too crazy, or kind of going a little bit over the edge. In the same way, Hyperopia means that the light converges right at the back. Now, nearsighted or myopia, there's no real easy way to remember that, unfortunately, but myopia or nearsighted is where the, the lens focuses the light, so the focal point is right in front of the retina. Now, the light rays are focused on the retina, and so the eyeball can be a little bit too long, or the lens can be not flat enough. Okay, so before it was not round enough, this time it's not flat enough. So it doesn't necessarily have to be the lens, but it could just be the length of the eyeball. Okay, so if the eyeball is too long, then it means that the focal point over here is actually over here, and we've got some pretty bad results for the person's eyesight. Now, so with myopia, the objects that are near are pretty clear, but objects that are far away are blurry. And they're corrected with what we call a diverging lens or a concave lens. Now that's, remember, the one that, doesn't look like this. The insides of it are not bulging out, but they're actually being pointed in. So I haven't really got a very good diagram of this, but if you can imagine, this part here is just the lens. Okay, so it's bulging in. We call that a concave lens because it's almost like a cave. It goes inside, just like inside the cave. Okay. Now, if you can remember that the convex lens brings the light rays in, then the concave lens is going to do the opposite. So you have the light rays come in here, and they're sent outwards. Okay, now that's pretty good for somebody if you can remember that it's a little bit too close. If you can kind of bring these outwards, it's going to mean that they sort of come in at a different angle and hopefully hit down on the back of the retina at the same point. So if it goes out, then hopefully it's going to send it out that way and bring it back in, so that the focal point lands right on the retina, just like it's meant to. And that means that the light's going to be a lot more focused, and you're going to have a lot more clear vision. All right, so just keep that in mind. Now, so just a little test. So if you have a far-sighted lens, okay, so remember, if the focal point is right on the end here, behind the retina is the focal point, then you really want to make sure that these can converge a little bit quicker. Okay, so you're definitely not going to want the light to go out. You're going to want the light to go in, which means that you're going to use one of these, which is the convex lens. Now, conversely, if you're nearsighted, you definitely don't want them to go in further any closer, because that means that it's just going to be a little bit more blurry by the time it gets here. So you want it to really be spread right out to make that area nice and big. Okay, so you're going to want to put a lens in front of here, which is going to open up these light rays, open them right up rather than starting to converge them. And that way, once the light reaches the lens here, it's actually got a chance to try and focus on the retina. And that's what the concave lens does. All right, good stuff. So again, so myopia is nearsightedness, and hyperopia is farsightedness. Okay, keep that in mind. Now, so the lens that is required to fix these conditions is obviously going to be different, because the problem is different itself. But really, the point is that you really want to get that focal point sitting right on the retina, and the best way to achieve that is through one of these kinds of lens. All right, well, I hope that kind of sorts some stuff out, and you've got some good information from this, and that'll help you out. So just in case you missed the lesson, or just in case you want to do a little bit more revision. Okay, so I'll look forward to seeing you guys in class. All right, have a good one.